All right, hi kiddos. How you all doing this weekend? I hope you're having a great time. Let's get straight to the point so we can get this over with, okay? So we're going to look at the absolute value function we're going to learn about right now. The functions that we have been looking at, in Algebra 1 we talked about the linear function, which makes a line, and the quadratic function, which makes a parabola. Well, the absolute value function is going to make a v. And the function goes like this: y equals, and then we use the absolute value symbol, which is 2 bars around an x. So that says the y equals the absolute value of x. Okay? Now the parent graph, we're going to go ahead and make the table quick, and then we'll go to the graph. Just a reminder, absolute value represents the distance a number is from 0. The distance a number is from 0. Okay? So let's start off right here with -3. -3 is how many units from 0? 3. -2, 2 units from 0. -1, 1. 0 is 0 units from 0, and so on. Notice all the numbers are positive. When you take the absolute value of a number, okay, it's going to be a positive outcome because distance is always positive. Okay, let's graph it. So we have -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. If I go too fast, remember, pause the video as you're doing this. Okay, it keeps on going, so we're going to put arrows on the end, and that is our new function. And actually, what an absolute value function is, it's actually 2 linear functions. Okay, when we have 2 functions, when we have more than one function put together, it's called a piece, write this down, piecewise function. This may be a quiz question, so don't forget it. Okay, here we go. Now we have some translations, or some transformations, some transformations. Well, here's how the general form goes. We have A, okay, times the absolute value of x minus h plus k. Now, absolute value is also a grouping symbol, okay, just like parentheses. So h means the same thing as it always has, left and right. K, up and down. A, vertical stretch or vertical compression. Okay, all the rules apply. So we start, notice that the parent has a vertex at 0, 0. Okay, so we're going to start at 0, 0. We're going to go 4 units to the right, 2 units up. So 4 to the right, 1, 2, 3, 4. 2 up, 1, 2. So our new, it's really not called a vertex, but I'm going to start calling the point that I move, I'm going to start calling that point right there, I'm going to call it my special point. Okay, I just made that up because there's a point on each function that we move, and in this case it's this point. So my special point, okay, so my special point moved 4 to the right, 2 up. Now we need to apply the a value. The a value is -1. There's a negative here and a 1. So we do the same thing. We go over 1. It's -1, so we're going to go down 1. Okay, it's symmetrical, guys. It's symmetrical about this point. So we're going to go over 1 the other way, and down 1. And then we can go ahead and graph it. Okay? So we have a reflection over the x-axis, translation forward to the right, and translation 2 up. Example 2. Now we want to write the equation. So the first thing I suggest that you do is you put your absolute value in. Okay? It got translated 1, 2, 3 to the left. So that's going to be x plus 3. 3 to the left. And it's got translated 1 unit down. So down 1. Now we have to check our a value. So from the vertex, we go over 1 and we count. 1, 2, 3, 4. It's 4 units to get to the absolute value function. So our a value is 4. So we have a vertical stretch. That's our dilation. We have a translation, 3 units to the left and 1 unit down. Okay, here are some practice problems. Let's do a couple together. It says graph each absolute value function. Include at least 3 accurately plotted points. Okay, so starting at the center, because this is our parent. This is our parent. So we always start at 0, 0 when we're transforming from the parent. Okay, so 3 to the correct, right. 1, 2, 3 to the right. Any up or down? Nope. Any stretch or compress? Nope. So 3 to the right. Our a value is 1, so over 1, up 1. Over 1, up 1. And there you have it. Okay, so the parent function got translated 3 units to the right. Okay, let's take a look at number 2. This time, the h is 0 and the k is 0. So that means we're going to stay right here. We're not translating any direction. Okay, we have a reflection over the x-axis, so we're opening down. And we have vertical. What do you think? It's greater than 1. So we have a vertical stretch. So we're going to go over 1, and it's down 2. 1, 2. Okay, it's symmetrical, so we go to the other direction, down 2. Okay, and so we have 3 points. And there you go. There's that one. Okay, let's see. Let's try number 5. So we got 4 to the left. 1, 2, 3, 4. Any up or down? Nope. Okay, now my a value is a half. So I'm going to go over 1, up a half. Over 1, up a half. And then I'm going to draw my V. And notice it's a vertical compression. It appears to be wider. Okay. So finish those problems. Okay. And that's all you have to do is finish this front page. And we will work on these problems on the back in class. I hope you guys are having a great weekend. I'll see you on Monday.